Good morning, everybody. I'm Henri, and I'm here to talk about flow-based programming. Ostensibly, flow-based programming for JavaScript, but I can promise there will be some polyglot aspects to this as well. Let's talk a little bit about concurrency first. If you've done something like PHP or probably Ruby or Python, you've probably dealt with this pattern quite a bit. The kind of call-return pattern where you call a function and the program execution stops until that function returns. So you're making a HTTP request, you're reading a file, calling some REST API somewhere, and your whole program stops while that thing is happening. This is very, very common in a lot of programming languages. And the problem is, usually in real life, there are multiple things happening at once. There might actually be two people visiting your website at the same time, and then you have to scale up by adding processes. In JavaScript land and in a lot of functional programming styles, this problem is solved by what's called the continuation passing style. So instead of waiting for a return value from a function, you call the function and you give it another function saying, hey, once you're done, call this function here. So you give it a continuation. And this allows the rest of the program flow under that to keep going while that particular function is doing some work. Now, this obviously has some issues. The first jQuery Ajax calls I made looked very much like this. A few levels deeper, I think, but that wouldn't fit on the slide. And I'm pretty sure most of you have written something like this. It just becomes very, very complex to manage, especially when you're talking about whole systems that are doing a lot of different things, not just this one particular place where things are asynchronous. And so it would be nice to have a map to your software, to be able to say, because we humans, we are very visual, we have this spatial understanding. You can look at this map of the London Underground, and you can pretty quickly figure out if you're at this station, how to get to some other station. But with software, we don't have this kind of a map, usually. We have a bunch of text files in a file system, and we need to load the text files, we need to read them, we have to parse the code, build a mental model about how things are related, and then that's the map. But we don't have a map we can just pull up and see how the different things in our code base are connected. But luckily this is kind of a problem that has been solved. The gentleman in the picture is John Paul Morrison. He's the person who invented the concept of flow-based programming at IBM in late 1960s. So we're talking about very bleeding-edge technology here. And once he retired, he wrote a book about it. This is the second edition. And in the book, he's describing how to build software that in a way that we can actually see what's going on, which is kind of nice. Now I need to explain how flow-based programming works. And to explain it, it's kind of good to know where the things are coming from. So at IBM in the 60s, the way you built information systems was you had these unit record machines, these machines that would deal with punch cards. And each machine would be configured to do some job. Maybe it would sort the cards, maybe it would put some cards in one pile, other cards in another pile, or maybe it would create new cards based on the cards you fed to that machine. So each of these unit record machines would perform one task on a set of cards, on a set of data. And then to make these machines actually do something useful, you had this spreadsheet or these workflow charts telling, okay, when you have cards in tray number 3, you take them and you put them to this other machine. And that's the way the software was actually built. There was the machinery component, the part that actually performs some algorithm, and then there were humans basically working as the message queue, taking a stack of cards and putting it to another machine. Now, since 60s we've moved forward, we don't need people in lab coats carrying our data packets around, but the basic idea is still the same. There are other people who thought of things in very similar manner. Alan Kay, when he was kind of thinking about object-oriented programming, he thought of it originally in a more kind of biological sense of things sending messages to each other. Then out of that, somehow we got Java, but the original idea was good. And this happy group here also had something similar in mind. With Unix, you had this idea of reasonably simple pieces of software that you could then connect with each other. And that's basically what flow-based programming is. If you've ever done something like this, if you've ever used the pipe character, sent the output of one program as the input of another program, you've already done flow-based programming. Though on the command line, it's usually just one-dimensional. You have this one line of like, do this, then do this, then do this. You can actually do splits and merges on the command line too, but it's so complex that people generally don't. So this is kind of where I come into the picture. So I did my time with PHP and Python, and I was somehow very frustrated about the state of things, and I was thinking, like, there must be a better way to build software. And as it happened, I was in US at the time, taking a road trip on the West Coast, and that gave me enough time to think about things in the evenings, read some papers. I ran into flow-based programming, and I ended up liking the concept. Something clicked there, and I implemented that in JavaScript, calling it NoFlo, which doesn't mean that things don't flow, it just means Node.js flow. This here is one of the original kind of NoFlo applications that I wrote. How many of you know Jekyll, the static site generator? Yeah, a few of you. Jekyll is quite a lot of lines of Ruby. This thing here is a clone of Jekyll done in NoFlo. So this graph here that you see, it's an executable graph. This is the source code that does exactly the same thing as all those hundreds of Ruby files does. And you can immediately see kind of how the different parts of the graph are connected. But this approach had a few shortcomings, and so what we did was we built a team and we moved the approach of NoFlo forward. And this is more like how it looks like now. So we visualize every process as its own box. These boxes have inputs and outputs. When a box receives data, it does something with that data, and it might eventually send some new packets out. So these boxes can be very simple. There's a couple of multiply by something boxes in that graph, or they can be very complicated. The things in the middle are GL shaders run on a video feed. So in the same, like, you can have very different levels of complexity in this kind of graph. So, but building a new way to program is complicated. And so last year we decided to see if, first of all, there's people who are interested in this. And secondly, if we could actually keep ourselves in bread and other necessities of life while doing this. And so we did a Kickstarter for the NoFlo development environment, as it was called then. And this was very successful. At that time, a year ago, this was actually the 5th largest software Kickstarter, which we used the money to actually build the IDE, and we released a beta last spring, and then finally delivered the Kickstarter plans a month ago. And with the Kickstarter, things really took off. It wasn't just about like getting some money to do these things. The bigger impact of the Kickstarter was that other people heard about the concept of flow-based programming, just like you're hearing about it right now. And apparently, it also clicked for some other people. And so, during the Kickstarter, we were just talking about JavaScript and CoffeeScript, about Node.js and the browser, since that was what we thought was relevant. But then other people came along. And so what we ended up doing and delivering was actually an environment that's completely polyglot. So out of the box, if you start using the tool, which we also had to rebrand to FlowHub because calling it NoFlo didn't make sense since it could run a lot of other things. When you start it up, it comes with a NoFlo environment. But then you can also connect it to a lot of other flow-based runtimes. In this picture, you see 2. So the one on the bottom, the graph there, and this little blank window, that's a flow-based programming environment for the GNOME desktop on Linux. So you can actually build traditional desktop applications visually. The one on the right is from MicroFlow, which is a flow-based programming environment for microcontrollers. So you can take one of those cheap little microcontrollers, you can plug in some maybe lights, some switches, whatever physical hardware, and then you can build the logic in this way. You can just connect boxes together. And the fun part is the guy who ported NoFlo to microcontrollers, he built it because he had a problem to solve. He had a fridge built in East Germany in the 70s that was broken. But he still liked the fridge, and he thought, throwing a fridge away just because the thermostat is broken is kind of wasteful. And so what he did was he took one of these microcontrollers, added some sensors, drew some software in this graphical interface, plugged it into his fridge, and now his fridge worked again. So suddenly, first of all, he has an internet-connected fridge built in East Germany in the 70s. And secondly, the first program, the hello world of his new IDE, gave him cold beer. And that's where kind of the fun starts, because you have these flow-based programming environments. So Node.js for Go, for Python, for microcontrollers, for browsers, for server, different environments. And you can combine these. You can say, okay, this microcontroller here is now a box in my Node.js graph. And then this Python process here is also a box in my Node.js graph. And these things talk together. And so this spring, to kind of show this concept, we built this table at the Seabase hackerspace in Berlin, which is, how many of you know the game Ingress? Yeah. So this table shows the Ingress game situation. It's an augmented reality game, so the playing board is the whole world. And this shows the Ingress situation around the hackerspace in real time with lights. So we have a map in the table, and we have these LEDs stuck in it that can be either green or blue, or they can show some state changes with colors and animations. And all of those LEDs are driven by a microcontroller that's running a microflow program. And then the logic, the information, comes from a NoFlo program that's running on a Raspberry Pi inside the table, talking to the Ingress API, converting the values, and sending data to the microcontroller. And so this is a fully polyglot table that you can have your beer at and charge your mobile phone. And that's I think, pretty cool. I will show the graph in a moment. So the first kind of takeaway from this talk should be that this kind of visual programming is possible. Currently, it works best for the kind of environments we are dealing with: browser programming, Node.js, Java on Android, microcontrollers, these things. But there's no particular limitation to these languages. You can do flow-based programming in anything. The processes, the little boxes you see there, could be whatever programming language you choose. This is more about the way you structure your software, how you connect things together. And so for that, before we go to the graphs, I wanted to show one thing, which is that the way we communicate with the different language runtimes is what we call the FBB protocol. So this is a message protocol which you can use to communicate from an IDE to a system running software. You can see what's going on there. You can change things. You don't actually have to ever stop the software. I think there was a sci-fi author who said that stopping software processes is murder. And we kind of took that into heart. We thought, okay, can we build software in a way that doesn't require us to stop it? And with flow-based programming, we can, because you can always remove a node, you can add a new connection, you can do all of these things, and you don't need to stop the software to do so. And this protocol is what we use for communicating from the IDE to the different environments, to the microcontroller, to the Node.js process, and maybe to your whatever Ruby, Python, whatever you're working with environment. So it's very easy to add new languages, and this is also the protocol we use for communicating between the runtimes. Okay, this is a little complex because I didn't have display mirroring, but here we go. So, first of all, the table, as I promised. So here we are. This is the graph that runs inside that table, and there's a lot of things. Here we fetch data from the API. Here we look at things. We run some animation loops. And these boxes are actually not part of the Node.js process. These are two separate pieces of physical hardware. As you can see, we are sending a lot of color values through here. We're saying, hey, make that light now brighter, dimmer, all those things. But now let's see a piece of software that we can actually run. So to do is the new hello world, right? And if we have internet, we will actually get this. No, we don't. Shit. Okay, PolyConf, where are you? Oh, it's coming. Yeah. Because like everything else in the IDE works offline, but these example graphs are coming from gists on the internet, so obviously they won't work if the network is down. Okay, well, then we do something local. So let's say PolyConf. And it's a browser project. Oh, by the way, I should mention something about the types. So here you can see the various runtimes that you have available. So these are actual running pieces of some FPP code somewhere, and you can easily register new ones. So if you look at the list, there's a few ones that we are aware of, like you can do Android, all these other things. Yeah, so let's go to that graph there. And now we have the scary empty canvas. So let's do something. Why don't we have internet? Okay, just a moment. Live programming is scary, and internet is not with us. Yeah, okay. I just disable the Wi-Fi, now it should work. Yep. Yeah.
Select the network.
Yep, just a moment. Sorry about this. Conference internet is always the fun stuff.
Okay, you can choose the PolyConf though. Yeah.
Okay. Okay, let's see. It's connecting. Ooh. Nope. Nope.
Okay, maybe try the other one.
Okay. The other network.
Okay, you try the, yeah?
Yeah, that one's dead. Okay.
Not sure.
Let's see. Ooh, network. Awesome. Internet. We are so lost without it, right? So, yeah, I was explaining about the runtimes. Now we can create the project again, that we actually have internet. Oh yes, this is true. That's even better than looking at this one. Okay, let's go back and use an example. So to do is the new hello world, right? Let's go again. And yeah, so how many of you know React? React is a JavaScript view library made by Facebook. It's open source and it's pretty damn awesome. And the interesting thing that the Facebook people did when they built React was they made it just a view thing. So React can react to changes in data and it can render those changes in the DOM. And it does it very quickly. So it doesn't provide any way of handling your data, your state changes, all these things. And so you always need something around React to be able to do those. And what they did was, before actually implementing anything, they documented, they wrote how they think applications should be built with React. And so they defined a concept they call Flux, which is a flow-based concept of building interactive applications. The basic idea is, on the right there, you see the actual view. This box here is a React component. It sends events out when something happens to here. The dispatcher looks at what kind of event it is, and it sends it through to the appropriate storage part, and then the storage is sent data back to the renderer. So you have this loop. And now let's run it. Okay, and so this is now a live NoFlo environment. We just started a NoFlo runtime. And what I can do here is I can create a to-do. I can create another one. And here you can see the events. These are the data packets that were sent from the React widget to the dispatcher. And the dispatcher looks at the type of the event. This is create, so we go to the create to-do subgraph, and here we actually create a to-do. So here you can see we first had one to-do in the list of to-dos, now we have two. And now if I click one of them, we send a different event. We send a remove event, and now you can see the to-do list changes, the React widget removes the to-do. So this is a very, very simple way to see how things are going. And the nice thing about building applications in this way is that not only you can see what's going on at any point, you can live debug any piece of software, whether it's on the server, on the client, and you can go and change things. We could remove that box and everything would break, for instance, but the software would still be running. We could replace that box with some other box. And that's pretty powerful concept. But the nice thing we are going to add in the next version of FlowHub, like this week or the next week, is that since this is a browser application, we can actually move the runtime between machines. Right now it's running in an iframe there on my screen, but in new FlowHub, I can flip that around and I can get a link and a QR code, and opening that link will open this same software in another browser. So I can take a picture of the QR code on my mobile phone, and this software will be migrated from that iframe to a web app running on my mobile phone, and I can still debug it exactly the same way. And just to show what I mean about like changing things live, let's start the clock. So here we have time moving, all these things, and now if we want to make the time move faster, we can do so. So I actually went and changed some configuration parameters of the running piece of software while it was running. This is disorienting because I'm running the same clock on my other screen and it's circulating still in the original time. But yeah, and you can constantly see what's going on. Like here, we send date packets through and they get transferred to rotations. And what else should I say? Yeah, these components, these boxes here, they can be other runtimes, they can be local things. It's basically just a function that defines these are my input ports, these are my output ports. You can write your own and connect them together, and that's how easy it is to build software. So, at this point, questions?
Can you open the box?
Can I open a box? Yeah. Unfortunately, not one of those yet in this version, but I can go here. And so some of these boxes are code. I can open that one, and I can actually see the code that's there. And some of them are other graphs. I can open it, and I can actually see the graph. So you can have graphs inside graphs inside graphs. These can run on different machines, different programming languages, and you can still debug and see what's going on with all of them. Anything else? Yes?
Wait.
So if I understood correctly, these nodes are pushing events to other nodes. And can you do something more similar to functional reactive programming, where they would just base the result on values from previous nodes?
Yeah, so in FBP, the concept is that you always send packets, and basically the data can only flow in one direction. So each of these components is completely blind to its environment. It just sees the data it gets, and it can send stuff out. It doesn't know anything about its surroundings. So that kind of limits the kind of puristic version of FPP kind of limits your options. But there are some environments like ImageFlow, the image processing engine we have integrated with this. There they do kind of smart handling. They see, okay, we are only rendering this part of the image, so we don't need to do the effect pipelines to the other parts that will be discarded, for instance. That's probably close to what you mean. Okay, anything else?
Hello, this is all very pretty, but how do you do version control and deployment?
All right, that's a good question. So, version control and deployment. So, I can always click the synchronize button and push and pull things from GitHub. So here, what it actually did was it compared the state on my machine to the stuff in Git, and it tells me, okay, those two files have remote changes, these ones have local changes, and I can either pull or ignore. And internally, each of these graphs, we store the full graph, but then we also store the operations history to the graph. So we know every operation you did. Like if I move this box around, that operation will be stored into the operation log, and that we can then reapply, revert those changes. And deployment, NoFlo doesn't generate code. The graph is just a data structure that we read, and then we build the connections at runtime. So you can deploy this as basically any config file could be deployed. We usually, like for server applications, we auto-deploy to our infrastructure from Travis when the tests pass. Anything else? I think we are more or less out of time. So I'll be happy to talk about this more over coffee, but at this point, thank you very much for listening.